Hello everyone. Today we are going to discuss about Kubernetes pod troubleshooting commands with examples. So in this video, we are going to cover Kubernetes pod troubleshooting commands with examples. So when working with Kubernetes, troubleshooting pod issues is a crucial skill. Pods may encounter various problems such as scheduling failures, crashes, or network connectivity issues. So this video provides a detailed step-by-step approach to diagnosing and resolving common pod issues during using various Kubernetes commands. So you can get this article from the link in the description. So the prerequisites are a running Kubernetes cluster, kubectl install and configure, and basic knowledge of Kubernetes concepts. So you can do a sample deployment by using this deployment service and customization.yml files. So I already deployed this sample application. So let's directly go for the commands with examples. So here you can check the pod status by using the kubectl get commands command. So this command provides an overview of pod statuses. So here you can see there are two pods which are running. So the common issues and solutions are like pending issue, the pod is waiting for resources. Like you can check the events by using kubectl describe pod and the pod name, and also check node status by using kubectl get nodes. So there is also another issue called crash loop backoff issue. So this issue occurs when the pod is crashing and restarting. So you can check logs by using kubectl logs by using pod name, and you can check health props in deployment YAML. So we are going to check these commands in next things. So the third one is the describe pod for detail info. So by using the kubectl describe pod and the pod name, you can get all the information of the pod. So it provides detailed information about the pod, including events and error messages. So pod name is example deployment. So I'll copy this and use the pod name. So you can see all the details. So here you can get all the details of the pod, including the start time labels, annotations, IP address, everything. So also here you can check the events also here by using this command of that pod. So the common issues and solutions are the image pullback issue. So check image name and register by using kubectl get pod and pod name with -o YAML. And you can manually pull the image by using the Docker pull and name of the image. So another issue is OOM killed. So it means pod exceeded memory limit. So you can increase resource limits in the pod spec and optimize the application's memory usage also. So the fourth one is you can check pod logs also. So by using the kubectl logs and the name of the pod. So here it fetches logs from the container running inside the pod. So let's check. So here I'll take the name of the deployment, and so here you can check all the logs of the pod like creating and all other things. So the common issues and solutions of this are, so when you get application errors, check logs for stack traces and fix the code. If your container restart in loop, you can use kubectl logs pod name, and you can check previous to check previous logs. So here the next one is execute a command in a running pod. So it opens a shell inside the running container to manually inspect and debug issues. So here you can use this command for that. There I'll go for the split screen. Wait a second. So here you can see the container got opened. So you can check, you can run the commands inside this container. So here common issues and solutions are file or dependency missing. So you can inspect the file system by using this command. So here you can check all the files inside the container by using this command. So you can also install missing packages if required. So you can also install the required packages in this container. So another issue is application not running. So you can check environment variables by using env. So to come out of this, you can use Control+D. So now, sixth one is the pod eviction due to resource pressure. So you can use these commands. So by using them, uh, by using kubectl get events, you can check eviction messages. By using kubectl top nodes or pods, it shows the resource usages. So here by using this command, you can see the events along with the creation timestamp also. So these are all the events with last in timestamps also. So here you can check the resources of the nodes and pods also. So, so by using top pods, you can check the resources of the two pods, like you can see memory and also you can see the CPU. By using nodes, you can check the CPU and memory of the node also. So our node is Minikube. So you can check these things. So here the common issues and solutions are. So the first issue is if node runs out of resources, you can increase node capacity or distribute workloads. So if resource requests are too high, you can optimize resource requests or limits in deployments. So the next one is restart a failing pod. So by using this command, the Kubernetes will delete the pod, causing it to recreate it. So if you delete the pod, the Kubernetes will recreate it. So it will be reset. So can use this kubectl delete command. So I'll copy the name of the pod. So here the pod got deleted, but here you can see the pod automatically recreating. So here you can see container creating. So the age is 4 seconds ago, which means the Kubernetes will automatically uh, start the container even after deleting. So here you can see the container is running. See, you can see the age is also it's of 20 seconds ago. So you can restart the container by using this command. So the common issues and solutions are if the pod stuck in error state, you can delete and let the controller recreate it. If there are any network issues, you can restart pod to trigger a fresh new connection. So another one is the DNS resolution failure. So here you can check logs of code DNS to identify DNS issues by using this command. So all these are the DNS issues. So by using this command, you can see all the logs of the DNS issues here. So here common issues and solutions are if the core DNS is down, you can restart core DNS by using kubectl rollout restart deployment by using this command. So if DNS policy is misconfigured, we can ensure DNS policy by using this command. So if there are any network issues, you can check if the pod has any network connectivity. So the next one is RBAC authorization error of forbidden. So by using this command, you can check if a user or service account has the necessary permissions. So here, wait a second. So here, you can use this command for that. So so here you can see the my user don't ha- don't have access to each the pods. So here you can see the answer is no. So that's how you can check user or service account has the necessary permissions. So here you can also check for the delete deployments also. So here it's saying no, so the user can't delete the deployment. So let's wait. So here the common issues and solutions are if there is incorrect role assignment, you can assign the correct role by using this command. So if the issue is like service account lacks required permissions, you can use kubectl describe and to this command to verify permissions. So here I'm not going to use this command now. So if you want, you can use it. So here the next one is ingress controller misconfiguration. So these are the commands to get ingress, to describe the ingress and to check the log of the ingress. So the explanation is you can use kubectl get ingress ensures ingress exists. So you can use kubectl describe ingress for checking for misconfigurations. So you can check kubectl logs for it. So it helps debug ingress controller issues. So let's use these commands. So we got an ingress. So the port number is 80. So name of the ingress is my app ingress. So I'll copy it. So you can describe this ingress. So it describes this ingress. So you can check the namespace, ingress class, everything here. So after that, you can check logs also. So these are all the logs from this ingress. So here the common issues and solutions are if the issues is backend service misconfiguration. So the solution is to ensure the service is reachable and exposable. If the issue is TLS configuration errors, the solution is to validate TLS certificates and secrets. So here the next command is etcd cluster issues. So here by using this command, you can check etcd availability, and by checking kubectl logs and etcd thing, it helps debug etcd errors. So here, so this is the name of the etcd. So it's running. So you can check logs also. So in place of the node name, I'll give this node name. So let's give this. So it is kube So I'll give this namespace name. So it's okay. If you want, you can use this and check this command. Let me try it once again. So here you can see these are all the logs. So it will help you to debug etcd errors. So now the common issues and solutions are. So the issue is if etcd is out of disk space, you can clear all snapshots and increase storage also. So if the issue is cluster inconsistency, so the solution is to check leader election and restore from backup. So the next one is the CNI plugin issues. So by using this command, you can check if CNI plugins are running or not. So by using the second command, it provides error details. So, so here you can see one plugin is installed. So you can check the logs of that plugin. So these are the logs of that plugin. So here the common issues and solutions are. The issue is CNA plugin missing or crashed. You can restart CNA daemon set. So if the issue is incorrect network policies, you can validate CNA settings and rules. So here the next one is invalid labels or selectors. So here the you can see these kubectl get commands and about selector and label. So by using this command, it lists all the matching ports. So by using this second command, it checks selector configurations also. So let's use this first command. So if you have a label, you can check. So I don't have anything. So here I'll use the describe. Let me check once. So if you can see, there are no labels. That's why the first command didn't work for us. So if you label, you can use that command. So here the common issues and solutions are, if the issue is mismatched labels, you can ensure pod labels match deployment selectors. So if the issue is incorrect service selector, you can update service YML to match pod labels. So the next one is persistent volume claim PVC stuck in pending. So to get the PVC, you can use this kubectl get PVC command. So we have a PVC which is of 1 GB here. So PVC name is example PVC. So you can describe the PVC by using this describe command. So you can get all the details of this PVC. So here you can see this is the volume ID of the PVC and capacity is 1 GB. So you can check annotations, storage class status, everything here. So you can use this kubectl get SC for available storage classes. So here the common issues and solutions are: if the issue is no matching persistent volume, you can ensure a PV exists with the correct storage class and capacity. So if the issue is storage class misconfiguration, solution is to verify and update the storage class in PVC spec. So next one is API server unreachable. So you can get the cluster information by using this command. So this is the information of the cluster. So by using this second command, it ensures control plane is running. So here you can see the control plane is running. So by using this kubectl config view, it verifies kube config settings. So here you can see this is the configuration of the kubectl. So here the common issues and solutions are: the issue is API server is down. The solution is to restart API server components. So if the issue is wrong kubeconfig configuration, you can verify the API server address by using this command. So the next one is network policy restrictions. So here, these are the two commands. So by using this first command, it lists all network policies. So by using this second command, it details the applied rules. So let's check. No resources are found as we don't have any network policy. So we cannot use the second command also. So here the common issues and solutions are: so if the issue is incorrect policy blocking pod communication, you can update the pod selector and egress or ingress rules in the policy. So if the issue is no network policy exists, so the solution is for that is ensure a policy is created for the required traffic flow. So here the next one is kube proxy issues. So by using this first command, it checks kube proxy availability, and by using this command, it inspects kube proxy logs for errors. So let me use this first command. So here you can see a kube proxy is available for us. So by using this command, you can get logs of that kube proxy. So these are all the logs of that kube proxy. So here the common issues and solutions are: if the issue is kube proxy pod is crashing, you can restart kube proxy pod by using this command. So here you can see the kube proxy daemon set is restarted. So here if the issue is IP tables rules are not applied, so you can manually reset IP tables and restart kube proxy also. So if you see the next one, service not accessible, which means pending or no external IP. So here these are the two comments. First comment is to get the service, and second one is to so here the second one is to describe the specific service. So by using this kubectl get SVC, you can get the services. One is of Kubernetes and another one is of our example deployment. So here, so by using this command, you can see all the details of the service. So here you can see which it is IPv4 or not. You can see the target port. You can see IP family policy, IP families, labels, selectors, annotations, etc. You can see everything here, the service point of view. So here the common issues and solutions are. So let me do this. So by using the first command, it checks if the service has an external IP or not. So by using the second command, it helps debug why it's stuck in pending. So here the common issues and solutions are: if the issue is wrong service type, so the solution is to ensure service type is load balancer if external access is needed. So if the issue is cloud provider specific issues, you can check for Azure, check application, gateway or Nginx Ingress settings. So if you see the next one, get detailed pod YML configuration by using this command here. So it displays the complete YML configuration of the pod. So here give the name of the pod, if no YAML. So here you can see the YAML configuration of this specific pod here. So you can check everything here. So displays the complete YAML configuration of the pod. So if you can see, the another one is check node status. So by using this check nodes over -OY command, it will list node details including status, roles, and the conditions also. So let's check once. So here you can see we got one node which is minikube. So you can describe the node also by giving the node name. So you can check everything about the node by using this describe command. So here you can see everything. So the next one is to check service endpoint. So by using this command, it will list endpoints associated with the services. So let's check the endpoints here. So here we got two endpoints. One is of Kubernetes and another one is our example service. So here you can see the next one is to debug network connectivity. So this is the command. So the explanation is it tests connectivity between pods and the services. So let me use this command. I have to give the pod name. The service name is example service and the port number is 80. So here you can see, thank you for using Nginx. So the connectivity between pods and services is good. So that's why we can see this output. So here you can see successfully installed and working. So this is about debug network connectivity. So you can view the config maps also by using this command. So there are two config maps here. So you can also check secrets also by using this command. So here you can see the secret, the type is opaque and data is one. So here you can also check the running deployments by using the kubectl get deployments command. So here you can see this is our example deployment, which are of two pods. So these are some necessary commands with troubleshooting issues and techniques. So in the conclusion, Kubernetes pod troubleshooting requires a combination of commands and analysis. By systematically checking pod status, logs, events, and resource usage, we can efficiently diagnose and fix issues. Mastering these commands will help you maintain a stable and reliable Kubernetes environment. So this is about Kubernetes pod troubleshooting commands with examples. So yeah, thank you.